About 65 million years ago, a catastrophic event forever altered the history of Earth. An asteroid, as large as a mountain, crashed into the Gulf of Mexico, triggering a chain of events that marked the end of an era. Traveling at an incredible speed of over 60,000 kilometers, the impact was devastating. The explosion released energy equivalent to more than 100 trillion tons of TNT, creating a crater 200 kilometers in diameter. This catastrophic collision not only caused the death of numerous living beings, but also brought about a radical change in Earth's climate, condemning approximately 80% of the planet's species, including the dinosaurs, to extinction. In a matter of moments, Earth underwent extreme transformations that would have lasting repercussions on the life forms that survived. Fortunately, events of this magnitude are extremely rare. However, given our current understanding of the cosmos, can we truly consider ourselves safe? While scientific advancements have improved our knowledge of space threats, the truth is that we still lack definitive solutions to defend ourselves against a potential impact from large asteroids. Stephen Hawking, one of the brightest minds of our time, raised an important point in his final book. He argued that despite our efforts in space monitoring, the possibility of an asteroid impact remains a serious threat for which we currently have no concrete defenses. Although the asteroid that caused the extinction of the dinosaurs was a unique event, science suggests we cannot completely rule out the possibility of something similar happening again. The laws of probability and physics indicate that it is only a matter of time before another asteroid approaches Earth, and the likelihood of this occurring is not as remote as it might seem. In 2012, a group of astronomers identified an asteroid with a 1 in 3,000 chance of colliding with Earth within the next 40 years. A few months later, in February 2013, another asteroid called 2012 DA14 passed just 28,000 kilometers from Earth, a distance that, while small in astronomical terms, would have posed an unimaginable risk if its trajectory had been different. Even more surprising, just 16 hours earlier, a smaller asteroid exploded over the city of Chelyabinsk, Russia. Its impact generated an explosion 30 times more powerful than the atomic bomb dropped on Hiroshima. Yet no one had predicted its arrival. Ironically, on that very day, scientists were monitoring a different asteroid that posed no threat at all. But how large does an asteroid need to be to cause significant damage? Let's consider different scenarios. Objects the size of a car, which strike Earth about once a year, typically disintegrate in the atmosphere and do not cause serious damage. However, an asteroid roughly 1 kilometer in diameter would release energy equivalent to 750,000 megatons of TNT. Such an explosion would create a 16-kilometer-wide crater, trigger a tremor similar to an 8-magnitude earthquake, and unleash a devastating shockwave traveling over 3,000 kilometers per second, destroying everything in its path. The asteroid that caused the extinction of the dinosaurs, however, was far larger. At 10 times the size of a 1-kilometer asteroid, its impact would have catastrophic consequences even today. Asteroids of this magnitude are rare, but they are precisely the ones capable of causing global catastrophes. Scientists estimate that an object of this size strikes Earth once every 50,000 years. Such an impact would lead to extreme climate changes and destruction on a continental scale. In 2004, one of the most feared asteroids, Apophis, measuring over 300 meters in diameter, was closely monitored. The probability of it striking Earth in 2029 was calculated at 2.7%, a statistic that caused significant concern. Had it impacted Earth, the energy released would have been equivalent to hundreds of nuclear bombs. Fortunately, subsequent calculations clarified that Apophis would pass only 30,000 kilometers from Earth, posing no direct collision risk. However, even though Apophis no longer represents an immediate threat, our solar system is populated by thousands of asteroids of similar or larger sizes that could appear unexpectedly. Scientists are exploring solutions to divert these threatening asteroids. One of the most promising options involves physical impact, striking the asteroid with a sufficiently large object to alter its trajectory. Other ideas include the gravitational tractor, a spacecraft that uses its gravity to nudge the asteroid off course, or a nuclear operation to fragment the asteroid. While these techniques show promise, they also carry risks, as the resulting fragments could still cause significant damage. In September 2022, NASA launched the DART mission, a groundbreaking experiment to test the possibility of deflecting an asteroid. The spacecraft collided with the asteroid Didymos, altering its orbit by 33 minutes. While a small step, the mission demonstrated that, with sufficient warning, we can indeed alter the trajectory of a dangerous asteroid. For now, none of the asteroids being monitored pose an immediate threat within the next 100 years, but this does not mean we can let our guard down. Our solar system may still harbor unknown asteroids ready to strike. Humans have faced extraordinary challenges throughout history. If another impact were to occur, with the right preventive measures and continued scientific innovation, we have the capability to confront it and protect our shared home, Earth. Thank you for watching. Don't forget to like, subscribe, and hit the notification bell to stay updated with our latest videos.